Hello everyone, how are you doing? It's Varun Srivastav and today we are going to talk about undirected graphs. So I wrote this article some time back, and at that time I was going through data structures and algorithm, and graph is one of the most important data structure that I found there. Without graphs there are so many things which cannot be even done. It's like it's not possible if we don't have graphs, and some of the uh, implications of graphs are we can see in our day-to-day life. Suppose you have to go from one place to another, you open Google Maps. It's a lot of edges only connected, and we have to find the shortest path between. So this is a perfect implementation of a graph. Then 10 million friendships in Facebook. This image is again shows the connection between each and every region of the world and how they are connected to each other. Then we have the map of science click stream. How many clicks are coming from which places? Then this is a Birmingham heart study. So again, they connected all the different sort of components together and to come up with this graph tool, which enables us to look better and understand better and get more information out of this. Then protein-protein interaction. That there are a ton of application graph in our day-to-day life. And today, what we are going to do, we are going to create a graph, and we are going to see how we can represent a graph in our programming language. And we are going to use Java for this one. Okay, so let's get started. So I created this workspace where we are going to code and create a graph. So I want to quickly cover what are we going to do as a part of this video. So first of all, we will look into graph representation, and then we are going to create graph API, like look at different methods that graph should have. And once we have the graph API, we are going to implement that API and create a graph implementation. So we are going to cover these three topics in this video, and if we have time, then we can also go through graph processing, because once we have graph, it is able to store the relation between all those different nodes and edges. But until and unless you process those information, you're not going to get something very useful out of this. So this part is very important when it comes to graph. So we will look into this as well. So let's see how can we represent a graph now. So when it comes to graph representation, there are different ways in which the graph can be represented. The first one is the 2D matrix. In this, we lay down all the edges and nodes in a 2D array. This is not very feasible, so usually we don't work with that representation. And there's another representation is the adjacency. Let me type it. The graph representation list. So this is the second type of representation, which is most commonly used and more efficient when it comes to processing the graph. So let's take a look at this representation. So in the same blog, as we scroll down, we come to this section. So this is how we can represent the adjacency list graph in our with our code. So on the left, you can see is the array of vertices. So these vertices, each vertex contains a bag which can hold other vertices. So let's say if you want to connect the edge from 0 to 6, that 0 will have its own bag, so that 6 will go into the 0 bag. So that's how we will know that 0 connects to 6, and the same thing will happen with the sixth one. So 6 will also connect with the first one. So likewise, in an undirected graph, there are two-way relation. So if A is connected to B, then B is connected to A because there's no direction. So let's see how can we create this representation in code. And the first thing that we will need is the bag representation. It can be a simple list, but when it comes to graph, we call it bag. That is the right name for it. So we'll create a class that will hold other vertices. So let's code. Okay, so to start with graph, the first thing that we need is a package. That's how we do it in Java, and we'll name it code with Varun. I really like this name. I don't know, maybe the sound of it is really good. Okay, so we'll create interface and we'll name it graph. This will cover the API part of the graph. So in this we will define the contract. Like if you are going to be a graph, then you need to have these, you need to give these functionality that we are going to write here in this API. So the very first thing that we need is of the ability to add edge from vertex 1 to vertex 2. Then the second thing that we need is you should be able to give me all the vertices if I want, and also you should be able to give me all the edges if I want in the graph. Then the next thing that we can have is a adjacent edges. Like if I give you a vertex, you give me adjacent vertices connected to that. So I will pass in the vertex, and I will want you, the graph, to give me all the adjacent vertices connected to this vertex. And since it will contain more than one, so it will be an iterable of integers. So I think we have a very basic structure of graph here, and we can work with this one. So next we will write the implementation for this one. Okay, so now we have the API ready. So now we can create and write the implementation for this one. So we'll create a adjacency list graph, and this is a graph, and it will implement the graph interface that we just created, and it will give us a bunch of functionality that we have to provide. But before that, if you remember, we talked about this one. We talked about the adjacency list representation, and we talked about this bag structure that will hold the actual vertices, that is connected to the vertex. So we'll create this bag structure now. So we'll create a class called bag. It can take any type, but for now we can keep it very simple and just go with the integers. And then we'll have a method to add, and we're going to add a integer here, and this list dot add. So we'll have a list. We'll create a list. Right now we don't have this list, but we'll create it. Then we need the functionality to give us all the vertices that it has. That will be an iterable of integer, and we will simply ask for all the vertices that you have. So we'll return the list, and now I'm thinking that it should be a set, because in list, the vertices can repeat itself, but we don't want it to repeat. We just want a unique vertex, because one vertex will be connected to another vertex only one time. So it cannot happen that vertex v1 is connected to v2 twice. So for that we will take a set of integer, and this is our list. And let's initialize this as well here. So this is going to be a new hash set. Cool. So we have our back representation ready. Now we will move to adjacency list graph, and we'll write the implementation for this one. Let's do it. It's showing some spelling mistakes, so let's fix that. Adjacency. This is very difficult to pronounce. List graph impl. Yep, not okay. Okay, so this graph, as soon as we create a graph object, we would like to pass the vertices to it. Otherwise, that's no use of a graph if it doesn't have the vertex. So we'll pass the vertices. Like how many vertices do you want to have in this graph. And for each vertices we need, so if we go back here, we see that each of this index, each of this vertex should have a bag. So that is what we are going to do now. So we go back in the code. So for that we would need a bag array, and this bags array. So first we'll initialize this bags array to this, and then how many bags do we want? We want the same number of bags as we have the vertices. So for each vertex we want one bag. So we are going to pass the vertices count. Now we are going to initialize the bags for each vertices. So that is what we are going to do here. So in the stream dot range, starting from 0 till the number that we have, and for each, what we are going to do, for each vertex we are going to create a graph. So so for each vertex we will have a new bag. Cool. What is the argument? Okay, I don't know why I passed it from here. Okay, so yeah, this is what we need to do. So now for each, so far we have made this part ready. So for each vertex we will have each one empty bag ready. So you will see what happens when the code grows. So now the next thing we have to do is to add edge. So now the person will tell us to connect vertex 1 with vertex 2. So it will pass us 2 vertices, and all we have to do is we have to go in that array of vertex 1 and we have to say key add vertex 2. So in this line what we are basically saying is that create an edge between vertex 1 to vertex 2, and since this is an undirected graph it will also be vice versa. So vertex 2 will also be connected to vertex 1. So this is how we can create edge. We can connect two vertices in a graph with adjacency list representation. Then the next thing we want to return all the vertices that we have. This is simple. We'll return the vertices, and for that we need to have the vertices. So we'll create the field. This is going to be integer, and here we are going to set two vertices. Awesome. This should be an integer. I'll make change quickly. Oops, sorry. It should be integer. So now I'm changing the interface here. So by mistake we wrote void here, which means that we don't want anything, but we want the number of vertices. We want a graph to return the number of vertices, and then we also want it to return all the edges. So how can we get all the edges? So for that we will be iterating over each of this vertex, and we will see how many edges it has. So it will be like a nested loop where we are going to count the edges. Cool. Okay, so for counting all the edges in our graph, we will have to go over each vertex, and we have to see how many vertex it connects with, like all the edges and vertices. Then we can count the edges it has. So we will go through each of this vertex. Let's do one thing first. We can rename this. The backs here, the name backs doesn't make sense here because these are actual vertex. And so what can we do? Vertices. So we are creating this variable just to return vertices, which doesn't make sense. Let's remove this one from here, and this could be backs.length, and our backs could then be renamed to vertices. So now it makes more sense. So our graph contains vertices and edges. Now we can talk in graph terminology. Okay, so now we need edges. So we will going to stream through all the vertices from 0 to the last vertex that we have in the graph. And for each vertex, we want the number of edges. So let's create atomic integer, because we are iterating with the lambda, so normal integers won't work, so we need atomic integer, and these are the edges. So now we can get the adjacent vertices, right? So we can get adjacent vertices by passing the vertex inside it. So far we have not implemented this method, which is this one, but we will implement soon. So what will this method do? It will simply return us all the vertices which this vertex connects with. For example, if we see here, so 0 is connected to 6 to 1 5, so it will give us, like, for if we pass in the 0 vertex, it will give us 6 to 1 5, all the connected vertex in respect to this one. This is what this method is going to do, this adjacent method that we have created here, this part. So we'll come to that. Let's first focus here. So let's assume we have all the adjacent vertices. Now for each of these vertex, we got to iterate them, and this is going to give us the other part, and here we can simply say edges.get and increment. So it will increment the edge count by 1, and then we can return edges dot int value, and again here we'll have to change this word to integer because we want the count. Okay, here as well. Sorry for this one, but yeah, now it will give us all the edges. Now the next thing that we have to do is to implement the edges, like how to get the adjacent vertices. This is very simple. So all we need is, we have the bags, which is the vertices. So for this vertex, we want all the connected edges, all the connected vertices. So I think you got it here, right? So this is a list of vertices in the graph. So for this vertex, we want all the connected vertices. So this is what we are doing here. So it will give us this list 6 2 1 5. And now if we see here, so what we have done is, we have iterated over each vertex, like 0 1 2 3 4 5, and for each vertex we ask for the connected vertex. So for like 0 we ask for 6 2 1 5, and for each of these connected thing we increment by 1, because these are 1 edge, 2 edge, 3 edge, 4 edge. So 0 to 6 1 edge, 0 to 2 second edge, 0 to 1 third, 0 to 5 fourth. But here we only counted it once. In undirected graph this is two way around. So if 0 is connected to 6, then 6 is also connected to 0. But so the edge count should not be double, because this is a single edge. But if we are iterating over this like this, then it will give us twice the number of edges. So that's why we can divide it by 2 and get the actual number of edges. I hope I'm making sense. If not, then please let me know. I can clarify further. Okay, so now we have a working adjacent graph. So let's write a test case to see if it is working correctly. Okay, so now we will write the test cases for this one. Actually, we should have done it before, but hey, nobody's fact checking. So let's create a test case now. And here we want to create an object of the graph that we just created. And let's quickly create that. Okay, inside this we have to pass the number of vertices. So this graph is now going to hold 10 vertices. Now what we want to test? We want to test whether the whether it is able to connect the edge from vertex 1 to vertex 3 or not. So it should connect an edge from vertex 1 to vertex 2, and then we are going to give it vertex, let's say 0 to 6, 0 to 5, 0 to let's okay 0 to 7 and 0 to 1. And how can we test it? So we can get all the adjacent vertices of this edge, so it will give us an iterator. So we can ask stream support to stream this iterator and give us a list. So now we will have a list of integer or adjacent vertices. So now we can test it very easily, like assert true. So we know that our adjacent vertices should contain actually it will give us a set. Yeah, it will give us a set. So collectors dot to set. Yeah, so it should contain 6 and 5 and 7 and 1. Cool. So let's see if a test case pass or not. It should pass. Yay, it passes. So we can say that 0 is connected to 6 and 0 is connected to 5. But we can also test one more thing, and that is whether the reverse is also true, like 5 should connect to 0. So what we are going to do for that, so we are going to pass in, let's say 5, and it should give us 0 here. So adjacent vertices 2 should contain a 0th vertex. So this should also pass. Now I will show you that it is working correctly. So this 5 is not going to be connected to 1. So if we pass in 1, it should fail. The test case should fail here, which means it failed, which means our program is working absolutely fine. So the next thing that we are going to do in this video is we will create a graph processing class, and that graph processing class will take this graph and will try to fetch the useful information that we use in our day-to-day purposes. Like for example, if you want to see what is the maximum degree of the graph, so we should be able to do that. And what if you want to see whether there's a path from point A to point B, so you should do that. So all these kind of things will come under graph processing part. So next we will take that. So now we can quickly create a graph processor. Here we will create another interface, let's say processor. Yeah, that's okay for now. And this is going to hold some methods that it will hold the processing part, like what do we want to fetch out of the graph, what information do we want. So I'll quickly go to my blog again and we'll see what are the methods that we can implement here. So we can implement degree, max degree, average degree, and number of self loop. Okay, so so it will give us the degree of the past vertex. So degree is like how many vertices are connected to the given vertex. So that will be the degree for it. Suppose our vertex 1 is connected to 3 different vertices, then the degree of that will be 3. So here what we need a graph, because that is the one where we are going to do the processing, and then we want the vertex. So for which vertex you are asking for the degree. So this will be a simple method, since interface is always public method, so we can remove that. Then we need the max degree. So integer max degree graph. Here we don't need the vertex because we will have to we just have to see which vertex holds the maximum degree and return the count, so we don't need to get the vertex for that. And then we can give average degree. This is a tuple. Next we will find the maximum degree in the graph. So for that we need to visit each and every vertex in the graph, and then for each vertex we will find the degree, and if this degree is greater than max degree that we have, then our max degree, let's create max degree first. So this will be max degree is an atomic integer int value. Then we are going to set a new value to it, and which is this one. Simply this. So now our max degree will be calculated, and then we can return the int value for this one. Okay, great. Now we will implement the average degree. So for this we have a direct formula. Since it could be in the fraction, so we will multiply two times the count of vertices divided by the count of edges in the graph. Then comes the number of self loops. So number of self loop is like if a vertex is connected to itself, it's like goes around like that. So here we can stream through each vertex. Oops. And for each vertex we will find the adjacent vertex. So for each adjacent vertex we are going to iterate over it and see if this adjacent vertex, if same as is equal to the vertex, then we are going to increment the number of self loops. So we can create self loops as an atomic integer and increment it by 1. So if it points to itself, then increment it by 1 and return the number of self loops int value. Awesome. So now we have implemented all the functions of a graph processor. Now we will write a test case to see if it is working fine. Okay, so now let's create a test case for this class, the graph processor, and let's create an object, assign it to a new graph processor. Then first we will test the degree. It should give the degree of the given vertex. So here we need a graph. So we will just create the object of the same graph that we created with 10 vertices, and we will create some dummy edges from 0 to 6, and let me expand this. 5, 7, 8, and let's say 9. Then let's connect 2 to 6 and 2 to 5, 3 to 9. I think this is good. Now we will calculate. So now we will assert that the degree of 0. So degree of 0 is 1, 2, 3, 4, 5. So our graph processor should give back 5 degree of 0th vertex. It should pass if everything is right. Okay, it failed. It means that we made some logical error. Let's check where we made the mistake. So we are oh, here's the mistake. We are iterating over each vertex. We don't want to do that. We simply want to get the adjacent vertex of the given vertex, and then for each, then we have to iterate over each adjacent vertex and increment the degree. Okay, we don't need this. Now it should pass. Yes, now it passed. So this method is correct now. Let's go back and write test cases for other functionalities. It should give us the max degree of the graph. Let's put it in a common place. So for that we can do before each, since it is JUnit 5, we can use before each void setup, and we can create this setup for us. So before each test it will run this code. Okay, and also we can create new object inside, so that way we will always have a new object to work with. Okay, cool. So now graph needs to be here, adjacency graph, and we don't need this there. Awesome. Now let's find out the maximum degree. So the maximum degree here is that I can see that 0th vertex is connected to the most of the vertices. So it's 1, 2, 3, 4, 5. So we should get 5 back here. Yeah, because that is the maximum degree as well in the graph. So we will pass the graph object and let's see if it works fine. Okay, it failed again, I think. Okay, it's a null pointer exception. I think we made some mistake here. So graph processor is null. Okay, my bad. So this should be graph processor. I don't know why I removed that. Yeah, it works fine. Now we will write test case for the other functionality, which was to count the average number of edges. So it should give us the average number of average degree, I think average degree. Yeah, so average degree is like twice the vertices. How many vertices do we have? 10, which is 20, and let's see what we were doing there. Let's simply print it out and see what it is giving. So graph processor dot average degree, and we pass in the graph. It will give us something. We'll print it out and see what it is. It should give us some number, which is 2.5. We know this is correct, that is why I'm doing it this way. Otherwise you should calculate manually and do it. So assert equals, we can give 2.5 here and same here. Awesome. So this will work again, and the last thing that we need is the number of self loops. It should give us the total number of self loops in the graph. So here we can assert equals, it should be equal to, we don't have any self loop here, so it should be equal to 0. Graph processor number of self loop, we'll pass in the graph and it should give us 0 back. But now if we add 1 from 0 to 0, now it has 1, so it should give us 1. Cool. So we have implemented a working processor for our graph. So quickly revise what we did in this tutorial video. So first we looked into the graph representation. We skipped 2D metrics because we don't use it normally. So we directly looked into the adjacency list graph representation, and we also implemented this one. We created a graph API that like what is the minimal requirement for for a class to be a graph. Then we wrote an implementation for that, and finally we wrote the processing logic, like what all information can we get out of the given graph. So this is very basic and very important. So let me know if you have any comments, any other thing, or if you want me to explain some parts of the, or you have any suggestion for my next video, please send it in the comments below. Thank you.